Once again, welcome to my YouTube channel. Now, today we're going to focus on Igcse additional math topics on trigonometry. Alright, let's get started. To trigonometry. Alright, now, my YouTube channel is located at Math Feast here. So basically, focus on explanations on mathematics and physics. Currently, I only have all the topics for A level and a bit of Igcse additional math. But in the future, I will add on more. Uh, as usual, if you like what you see, do subscribe and then press the notification bell so that you receive the feed for the next video that I'm uploading. Okay, let's get going with the next section of trigonometry. Okay, now in this case, let's start with, let me unblock this. Okay, where should I put this then? Okay, let me put it down here. Okay, right. Okay, now on the screen, you are having a right-angled triangle. Okay, this is a right-angled triangle here, right? Okay, now the objective for this section is how are we going to make use of this geometrical shape with all its length to produce the well-known trigonometric equations. Okay, all right, now there are many trigonometric equations that we can form, but for these sections we are only interested in some of the few of the very famous trigonometric equations that we can derive from the property of the geometry itself, right? Okay. Now the first technique that we're going to use to derive the trigonometric equation is by using the Pythagoras theorem, right? Okay, because this is a right-angled triangle, so according to Pythagoras theorem, we have c square equal to a square plus b square here. Right, that is based on Pythagoras theorem. Okay, right. So make sure you're clear on Pythagoras theorem here, right? And then from this Pythagoras theorem equation, let's try to recall some of the trigonometric ratio that we can relate to this triangle here. Okay, so take for instance, I'm going to write it down here just for a reference. We have a sine theta, which is given by the length of the opposite against the hypotenuse. So therefore we have B over C. And then we have cosine theta, which is given by A over C. And then finally we have tangent theta, which is the opposite over the adjacent length. Right, now these are the common trigonometric ratios that we have seen all this while, right? Okay, now how are all these length relates to the ratio itself? We can see it from here. This is the relationship between the length for the geometry and the introductions of trigonometry ratio. Now we're going to extend this further by creating trigonometric equations based on this famous three or maybe more trigonometric ratio that we're going to introduce in a while, right? Okay, now firstly, by using this Pythagoras theorem's result, we can manipulate this algebraically any way you like. Okay, take for instance, in this case, I can I can, okay, let's label this, is easier to work with. So I'm going to label this as my equations number 1. So take for instance, I would like to take my equations number 1 divided by, let's say, c squared. So I'm going to divide the whole equations by c squared. So therefore, I will have a squared divided by c squared plus b squared divided by c squared. And then on my this side here, I will have 1. Okay, and then next I can further describe this in a more suitable format. For instance, which is equal to 1 here. All right. Okay, now at this point, we are going to refer back to our normal trigonometry ratio that we have set up here. Okay, we are going to check whether we have anything that we can relate to the ratio itself. First of all, a divided by c. Let's check. A divided by c is given by cosine square, and then b divided by c is given by sine square. So therefore, by using substitutions, so we can write this as okay. Now this is the normal conventions how we write the square of a trigonometry ratio here, right? But sometime or most of the time textbook would prefer to write this in this form. All right. Just to make everything clear, this cosine theta is one mathematical object. So even though the square is on top of the cos, it doesn't mean that cos is one object and theta is one object. You have to treat the cos theta itself as an object. So we are actually squaring the trigonometry ratio cosine theta, and then not squaring the cos in this case, right? I hope this is clear, just to prevent any confusions on this, right? Okay, now we have indirectly set up the first trigonometric equations, which is given by equation number 2 here. So that's our first trigonometric equation. All right. Now next, from these first trigonometric equations, we can further derive the other 2 famous trigonometric equations, right? By manipulating this algebraically again, right? Okay, now from here onward, I can actually divide. For instance, if I like, I can actually divide number 2 with cosine square, for instance. So I'm going to divide the whole equations by the ratio cosine square. By doing so, I will have 1 here, because cosine square divided by cosine square is a 1. And then this will become a sine theta over cos theta square. And then this part I will have cosine square theta here. All right. And then now for this format, I might like to introduce some extra trigonometry ratio so that we are more familiar with this, because this format is kind of complicated. Mathematicians prefer to simplify it further by introducing different types of trigonometry ratio, right? But before that, you need to recognize that tangent theta can be written as sine over cosine. So that is the relationship between these 3 trigonometry ratio, right? Now for this next section, I'm going to introduce 3 other trigonometry ratio, which we're going to fit into our next 2 trigonometric equations here. So the first one is, by definition, the reciprocal of cosine. Now the reciprocal of cosine is known as secant theta. right? Okay. Now the next reciprocal ratio for sine is known as cosecant here. And then lastly, we have another trigonometry ratio, which is the reciprocal of tangent. This is known as cotangent. So by using this 3 plus another 3 ratios here, we have in total 6 trigonometry ratio that we're going to use in our next trigonometric equation, right? So from here, how can we simplify this using the new trigonometric ratio here? Okay, now we can do this in this case. So from this equation that we have set up, we can rewrite this as tangent square theta, tangent square theta, and then 1 over cosine square theta can be written as, because reciprocal of cosine theta is actually secant, so therefore 1 over cosine square theta is actually secant. And then there you have it, that is our equations. Trigonometric equation number 3 there. Okay, so I hope that is clear. Alright, and then lastly, I'm going to derive the last trigonometric equations that we can make use of in our next section. Right? Now before that, I'm going to clean up a bit here. So let me clean up the one that we don't need here. Okay, I will still be making use of the first trigonometric equations that we have derived. So with reference to sine square plus cosine square equal to 1 here. So I'm going to use this as my reference. Now instead of dividing that equations by cosine square, what I'm going to do is I'm going to reverse the process. Okay, before that, let me clean up everything here. I'm going to leave the 6 trigonometric ratio here for reference. Okay, now I'm going to label this one more time as my equation number 2 to work with. Now previously I divide my equations number 2 with cosine square. So this time I'm going to take my equations number 2 and then divide everything by sine square. So let's see what will we get from here. So if I divide by sine square, I will have a 1 there. I would end up with cosine square sine square here. And then this would give me a sine square theta. Alright. Okay. Now from here, we notice that cosine theta over sine theta is basically the reciprocal. This is actually the reciprocal of tangent. So I can actually write it down as reciprocal of tangent square. This one I will fix this as sine square here. Right. Now next we're going to refer to the reciprocal trigonometric ratio that we have set up here. Okay, so based on this ratio, we can rewrite this as 1 over tangent theta as cotangent theta. So therefore these equations can be turned into cotangent square, and then reciprocal of sine is given as cosecant. So therefore I can rewrite these trigonometric equations as 1 plus cotangent square is equal to cosecant square. And then there you have it. That is my 4th equation. So to conclude all the equations, all the trigonometric equations that we have set up, they are number 1, we have it here. I just rewrite again. So sine square is equal to 1, and then the next one would be 1 plus tangent square theta is equal to secant square, and then lastly we have 1 plus cotangent square, which is the same as cosecant square here. So these are the three trigonometric equations that we set up based on the ratio of the length of this right angled triangle, and then by using the concept of Pythagoras theorem here. Alright, now I hope that is clear to you how these trigonometric equations was set up, and then the newly introduced trigonometric ratio, other than the normal three trigonometric ratio that we have: sine theta, cosine theta, tangent theta. We can also have a secant theta, cosecant, and then cotangent. Right. So I hope the first sections is clear. Now the next sections would be excuse me. Now the next sections would be we're going to look at the applications of these trigonometric equations. Now we don't just set these equations up just for display. They are here to help us to simplify certain problem, and then we may actually extend its ability to further solve other trigonometric problems. Right? So let's move on to the next sections. How are we going to make use of our trigonometric ratio that we have set up? Okay. So before that, let me clean up everything. All right, let's move on to the next one. Okay, now the first usage of the trigonometric equation is we can actually use it to solve some types of trigonometric equations, other trigonometric equations. We can solve them using the trigonometric equations that we have set up. Now, sometimes they also call these trigonometric equations as trigonometry identity. So other than calling it trigonometric equations, they are also known as trigonometric identities, right? So just let me rewrite one more time those identity again so that we can recap. So we have, okay, we have that. Let me use the proper one. Okay. We have sine square theta plus cos square theta equal to 1. We have 1 tangent square, which is equal to secant square. And then lastly, we have this. Alright, so these are the three important trigonometric identities that we're going to use it to solve this problem here. Okay, let's get started to solve this. Right. Okay, you can read through the question here. Here it is stated that we need to solve cosecant x equal to 5 with reference to the domain for x lying between 0 to 2 pi radian. Okay, now first of all, you need to recall cosecant. I just want to write down here one more time so that we don't forget this. Cosecant x or cosecant theta in this case is basically 1 over sine. Right now, most of the time we will confuse cosecant by writing 1 over cos x because it does rhyme with cos. So be very mindful with the reciprocal of sine. Right? Okay, so based on this question, we can rewrite that cosecant is 1 over sine. So we are more familiar with sine than cosecant. And then, by the way, most of your calculator that you use in school only allow you to compute trigonometry ratio sine. instead of computing cosecant here. Right? So from here we can rewrite this as sine x equal to 0.2. Okay, and then from here onwards, okay, we are going to recap the steps on how to solve this trigonometric equation. So first of all, you would figure out the reference angle for this for sure. So how do we find the reference angle? We get to locate the reference angle by using the arcsine or the inverse sine function that is found on your calculator. Okay, so arcsine 0.2 here. Okay. Now let me take out my calculator and then let me key that in. Let me see what do I have there. Okay, so just let me make it smaller a bit. Alright, too small already. Okay, hold on. Just let me go back to the previous one. Yes, this is where we are. Okay, so let me get this one more time. So we have arcsine. Okay, so just let me clear everything. Okay. For arcsine, I will have. Let me see what do I have here. Okay, now if you are using calculator to compute this, most probably you will end up with 11.54 degree. Okay. Now, if you switch your calculator mode to radian, yes, you will be able to get the angle in terms of radian. Now, based on my calculator, I need to do a bit of adjustment. So it's a recap. The way to convert degree to radian is by multiplying the angle in degree by pi and then divided by 180. So therefore, I'm getting the reference angle as 0.2. Just let me get more decimal place here so that it's easier. Yeah. So the reference angle that I have obtained is 0.2014. So just let me capture that. So this is 0.2014. Right. Now that will be my reference angle. Okay. And then it's always good at this point to use visual context to help us to relate to what we are actually finding. Okay. So just let me roughly draw this. Okay. Now in this case, when you look at this equation itself, visually we are saying that we have a sine graph. Okay, we have a sine graph within this domain here. That domain is from 0, pi, and 2 pi. This is x. This is a y here. Okay. Now, if I were to sketch the graph for sine, I would end up with something like this. Okay, something like this. So that will be my sine graph, right? Does not look very good here. Just let me clean up that again. Just let me redraw again. There's a delay in my line here. Okay, now it's better. Okay, so that will be a sine graph in this case. We are saying that what is the solutions when this sine graph meet with a straight line y equal to 0.2. So basically we are trying to find the intersection point between this straight line y equal to 0.2 and the sine graph y equal to sine x. we can see that there are two solutions or two intersections points which are here. And then the first answer has been discovered here, which actually refer to our reference angle here. All right. Now next we're going to get the second angle, and then by using symmetry, in this case, we are quite certain that in this case, the other angle must be the difference between this pi and the reference angle that you are looking at here, right? So therefore we can conclude that the solutions, all the solutions that we are getting, can be given by x equal to 0.2014, which is the reference angle, and then by using symmetry, we can take pi minus 0.2014. So that will be our solutions there. So just let me get my calculator and then compute this to see whether we got this correct. Right. So we take pi minus a there. So we get our final answers to be 0.2014, and then the other solutions is 2.9402. Now, of course, for exam purpose, you can leave it as minimum 3 significant figures or more. In this case, you can leave it as 201, and then the other one is 2.94. Right? Okay. So just let me check. Like in the exam, once you have obtained the answer, you might like to find out whether what you are getting is correct or not. So it's always good to check. Okay, now checking, we're going to check by substitute all our solutions back to the cosecant there, which is 1 over sine x, to see whether we are actually getting a 5 or not. Right? So let's check that out in case we make mistake. Okay, I might make mistake also. So okay, here, because I'm using a software, so I'm going to check using the functions that I have in this software here. So I have cosecant, which is 0.201. Hold on. Okay, so that does not really look like it's correct, because that is negative 1.5, so which means there is something wrong with the answer then. Okay, hold on, just let me check one more time. Okay. After checking through, I found that yes, it does give me the value that I wanted here. So by substitute 0.201 into the cosecant functions, it will give me a 5 here. Right? And then if I substitute the other solutions, that would also give me approximately a 5 here. Right? So in this case, I'm quite happy with my result. Right? Okay, so I hope that is clear for this question here. Okay, just let me clean up the screen here. Alright, let's move on to the second one. Okay, now solve each one of these equations below given the domain specified here. Now the same thing again, I'm going to rewrite all the trigonometry ratios that we need or may not need. Okay, in this case, we have sine square plus cos square theta equal to 1 plus tangent square theta equal to secant square. We have 1 plus cotangent square theta equal to cosecant square theta, and then don't forget the reciprocal of sine is cosecant, and the reciprocal of cosecant is sine. Sorry, cosecant. Hold on, I rewrite the wrong one. Just let me clear that. The reciprocal of cosine is secant. And then lastly, the reciprocal of tangent is cotangent. So in this example, we will be dealing with the cotangent here. Okay, so let's get started with this. All right. Now, first of all, we are going to convert these cotangents using this ratio that we have set up here. Okay. So from here, we know that this is 1 over tangent. Okay. Now, before we continue with this, I almost forgot. Even though the domain given to us is within 0 and 2 pi, based on the trigonometric equations given to us, we may have to do a bit of adjustment to the domain in this case. So let's try to convert that. If we convert this domain, if we have x plus 3 pi, so therefore it will be a 2 pi plus a pi over 3, left hand side and right hand side. So this one will become this. Originally it was greater than 0, less than 2 pi. But once you introduce the pi over 3, you have to add up both sides here. And then finally we end up with, just rewrite this, this is a reminder. So we end up with like 7 pi over 3. Now this is sort of our new reference domain for us. Okay, so we are saying that the answer for x plus pi over 3 must be lying between here. Okay, so now we can get started to solve this. Okay, so instead of using cotangent, we can write that down as 1 over tangent tangent x plus pi over 3 is equal to 2. Okay. From here, we can simplify that as this, which is equal to 0.5. Okay, I hope that's clear. Right. Now, from here, again, you can actually treat this x plus pi over 3 as alpha, for instance. It's easier to work with in this case. So this is actually alpha itself. So instead of looking at tangent x plus pi over 3, we can say that tangent alpha is actually equal to 0.5. So how am I going to find out the reference angle in this case? So I'm going to work with the reference angle first. Reference angle will be arctangent 0.5 here. Arctangent 0.5. So again, let me get my calculator. Hopefully it's working properly this time. Sometimes it malfunction. So arctan 0.5. Okay, that is what I have, but because the result has to be in radian, so I need to convert that using a bit of formula here. I'm getting myself 0.46. Just let me change the decimal places to get a more accurate answer. Okay, so I'm looking at 0.4637 radian. This is 0.4637 radian. Okay, so that is my reference angle at this point, right? And then don't forget, for those of you who are using this method, this chart, to help you to relate to all the possible solutions within that 360-degree domain, you are using this mapping. Okay, if you are using this mapping, we know that the tangent is positive in the third quadrant, and then that would, okay, you can actually use a shortcut, even though this is not a very appropriate method, but it's a shortcut way to obtain the solutions. So if we say that if the solution is found in this quadrant, then we will use this formula here to obtain the solutions here, which is pi add up with the reference angle. If they fall in this quadrant, then it will be pi minus alpha. And then if it fall in this quadrant, it will be 2 pi minus alpha, where the alpha refers to the first solutions in the first quadrant. Right? Okay. So at this point, we need to write down all the possible solutions that we have. Therefore, we're going to write that down because alpha is x plus pi over 3. So I'm going to rewrite x plus pi over 3 one more time is equal to the first reference angle that I have found out. And then I also know that because this is tangent, it should be located somewhere here also. That would give me a pi plus 0.4637. Okay. Now, other than that, I also need to make sure that it will fall within this domain here. This 7 pi over 3 is already more than 360 degrees. So therefore, I might want to consider another turn. Okay, by considering another turn, I will have to take 2 pi because one complete cycle is 2 pi. So I'm going to add this with 0.4637. Okay, at this point, I think I'm ready to obtain the solutions now for x. Therefore, my x would be, okay, I need to take out my calculator on this because there's so many numbers to work with. Okay, just be patient with me for a while. All right. So I'm going to take like the first one minus of pi over 3. Okay, let me see. Based on the answer that I got is a negative 0.5835, which is actually out of the domain here. The original domain for x lying between 0 and 2 pi, but if you take the first solution, you will end up with negative 0.5835, which we need to reject. So this part we need to reject because it's outside of the domain. So next we're going to, since this is cannot be accepted, we're going to work out the second one. So let's look at the second one then. The second one will be pi add up with that, and then minus of pi over 3 there. So we got ourselves 2.56. Is 2.56 within the domain, or always check? Yes, it is within the domain there, which is 2.56. So I'm going to take it. And then lastly, I'm going to check whether the last option is also part of the solutions there. Just let me clean this up a bit. Okay, so the last one, just let me try that. That would be 2 pi plus a c minus of pi with 3. So in this case, I got myself 5.7 approximately. 5.70. Now that will be my all the solutions that is possible, right? Because 2 pi is around 6.28. So 5.7 should be the last solutions that I should expect to have here. If I try out the next one, it should be outside of the domain of 2 pi there. Okay. All right. So I hope that is clear for everyone at this point. Okay. Now let me clean up everything, and then let us move on to the next one. Okay, next one. Right. Now this is the second questions involve secant. So again, I will rewrite the ratio one more time as usual, just to remind ourselves again. So sine theta. Maybe this time I'll leave this part here so that I don't need to erase that again. So that is cosecant. Don't forget, 1 over cos is secant, and then 1 over tangent is cotangent. Okay, all right. Okay, let's try to solve this here. As usual, we try to convert this into the ratio that we are more familiar with. Secant, we can see the secant is related to cos itself. So this can be written as 3 over cos 2x plus 3 equal to 4 here. And then we can rewrite this as cos 2x plus 3 is actually 3 over 4, which is 0.75. Right? Okay, don't forget, after we've done this, we need to change the domain itself. Okay, so because the domain given is related to x, in this case we have 2x. If you multiply 2 here, it will be greater than 0, greater than 2 pi. And then don't forget, if you add up with 3, that will be a 2 pi plus 3 on this side, 3 on this side. So we need to refer to this in a while, right? And this one also right here. Okay. Right. Let's continue from here. As usual, we are going to maybe it's best to label this as alpha. Okay. So we look at how am I going to find out alpha in this case. The reference angle, I'm going to take arc cos 0.75. Arc cos 0.75. As usual, I need my calculator on this. Okay, arc cos 0. Did I key the correct one? Okay, arc cos 0.75. Okay, that is in term of degree. 4096. Okay, let me convert that to a radian. Okay, that's 0.723. I'll write that down. 0.723. Okay, there you go. That's my reference angle. And then from here, I noticed that this is a cos. So a cos is positive in the 4th quadrant. I just redraw this diagram for reference. It's not the best way. The best way is still by drawing out the graph itself. Okay, so this is CAST here. Okay, so from here I can sort of conclude my 2x plus 3 should be equal to 0.723 here, or it could be 2 pi minus 0.723 because it's fall in the 4th quadrant here. And then don't forget, in this case, because the domain is if you convert this to decimal, there will be 6.28, so there will be 9.28. So I can actually get one more round, for instance. Okay, so sometimes if you don't know how many domains you should get, maybe it's best to try one more round to cover all the domains that you think is possible in this case. So I'm going to take that 2 pi add up with 0.72, that is to turn one more round, and then finally I'm going to add up one more round to this in case in case I miss out any solutions here. So I'm going to take out one more round, so that will be 2 pi plus whatever I have here. So it's 2 pi minus 0.723. Okay, so from here I can work out my answer for this. Okay, so that is, now in this case it will be, I will try to simplify it directly from here. Okay, maybe I'll just do 2x first. Now based on my calculator here, if I take 0.723 minus of 3, that must be a negative number, which is already outside of the domain. So I'm going to sort of skip this, right? So I'm going to move on to the next one. So just let me calculate the second one here. Now that would be 2 pi minus 0.723, and then I need to take that by subtracting a 3 also. Okay, so that is 2.56. So I'm going to write that down. 2.56. And then next one I will have, okay, let's see what we have here. We have 2 pi, add up with 0 plus 2, 3, and then I need to minus off by 3. Okay, so my next solution is 4.01, for instance, which is this. And then lastly, okay, that is blocking the way. Just let me reduce that. Okay, so lastly I have, just let me key that in. That is actually 4 pi minus 0.723, and then minus of the 3. So that will give me 8.84. This is 8.84 there. And then finally I need to divide by 2 all of this. So that will be like, okay, just let me try this. 2, 8. So this one will be like 201, for instance. And then this one will be 4.42. And then finally I need to check whether all these solutions are located within the domain here. This is the final domain, whether they are located in this domain or not. Okay, I need to check. 1.28 is okay because this value here is 3.142. Okay, but I accidentally included one which is outside the domain. So from here I can conclude one more time my final solutions to be 1.28 and then 2.01. And then sometime in mathematics you can write, I'm ready to chow. Okay, not chow down. Okay, so I hope that is clear to you. Alright. Okay, let me move on to the next one. Okay, next one. Next one involves a quadratic form of trigonometric equation, right? Because of the format itself, I will rewrite the identities that we might need. So we have sine squared theta plus cos squared theta equal to 1, or we can have 1 plus tangent squared theta equal to secant squared theta, or we can have 1 plus cotangent square equal to cosecant squared theta. Right, so that's all we need here. Okay. Hopefully it's useful at this point. Okay, let's look at the question itself. Solve secant square x equal to 4. Right. Solve secant square x. Now if you like to use this, you can actually go ahead, or we can solve it using the reciprocal. So here I'm going to show you two methods. One is by using the reciprocal of a cos. Cos is because reciprocal of cos is actually a secant. Reciprocal of cos is secant, so we're going to make use of this. In this case, other than that, we have sine, which is cosecant, and then finally tangent is a cotangent, just as a reminder here. Alright. But in this case, we are going to make use of this one. So first method number 1, we're going to use the reciprocal ratio. So this can be written as 1 over cos square x is equal to a 4 there. Yeah, because secant square is 1 over cos square. So from here we can rewrite that as cos square x is equal to 1 over 4. 1 over 4. And then from here we can simplify this as plus or minus 1 over 2. Because square root, so don't forget your plus or minus. Now let's consider one at a time. We can consider cos x is equal to a negative half, or we're going to consider cos x as half here. Okay. Now both of these reference angle is the same, so I'll just write down the reference angle alpha, which is given by the arc cosine. Don't forget, whenever you figure out the reference angle, we don't input negative when we compute the arc cosine. So we just compute arc cosine positive half. If you press your calculator on this, you will end up with 60 degree. Okay. So therefore, for case 1 here, for case 1, the solutions for this, because it's negative, so it should be located. Okay, so for this, I'll write this one down. It should be located in these two quadrants because it's negative. Right? So therefore, I can conclude that my x is actually 180 degree minus of 60. I'll just rewrite this so that you know what's going on. And then the other one is 180 plus 60. That would actually give me 120 degree. And then the other one is 240 degree. That's my first solutions for my first case. Now, for my second solution is easier. The x, it just first, for this, the quadrant is positive for A and C. So the first one, 60 degrees here. And then the last one is 360 minus of 60. So therefore, I can say that this is actually equal to 60 degree and then 300. And then finally, all the solutions. We need to write down all the solutions there. So all the solutions that we are looking at refer to x, which is we're going to arrange that in an ascending order, so it's easier to recognize all these informations that we are looking at. 20 degree, 240, and then finally we have 300 there. Yeah, of course it's always good to check, like entering 300 into here to check whether it's equal to 4. So as usual, even though we are quite confident with this, but checking is always a must in the exam. So just let me try that out in case I make mistake also. Okay, so secant, let's deal with 300. Yes, it's a 4. And then you can try the rest. No? You will find that the answer are all equal to a 4. So for this, we are a very happy person here. Right? So I hope this is clear for everyone. Okay, so let's move on to the next one. Before that, let's clean this up. Okay, next one. Alright, now it's another trigonometric equations that we are looking at. Okay, oh yeah, before that, as I said, I almost forgot. Hold on, just let me go back there. As I said, we can actually solve these equations using the three trigonometric identities that we have set up. Okay, other than using the reciprocal. So just let me rewrite that trigonometry identities that we have set up just previously. So one of them is 1 plus tangent theta is equal to secant square theta. We also have, I'll just rewrite this one more time. And then 1 plus cotangent square is equal to cosecant. Yeah. But in this case, I will be using this trigonometric identity to solve this instead of using the reciprocal. Right? So how am I going to solve this? All right, now by using this equation here, this identity. Okay, to do that, I know that secant square is equal to 1 plus tangent square. So here I can write down 1 plus tangent square is equal to 4. So from here, tangent square is equal to 3, and then by taking the square root, we've found that we have both plus or minus here. So as usual, we're going to consider the two cases here, or tangent theta is equal to square root 3 here. Right? Now, as usual, we have to work out the reference angle. Both reference angle is the same by taking the arctangent in this case. Don't forget, don't put a negative there. If you key into a calculator, then this would also end up with 60 degree. Yeah, this is actually 60 degree. Okay. Now from here, we can look at case number 1 here. For case number 1, oh yeah, I'm using the wrong symbol here. Just hold on. So let me clean that up so that you don't confuse on the symbol that I'm using. Okay. That's why we need to always check. Okay, so this is the symbol that I'm supposed to use here. And then from here, we can conclude the first case as x, because tangent is negative. So tangent is negative here, and then tangent is negative this side here. So therefore, we can conclude that this is actually 180 degree minus 60 degree, one of them, and then the other one is 360 degree minus of 60 degree. So that would give us 120 degree, 300. Okay, that's first solution. And then for case number 2 here, the x, because tangent is positive, so tangent is positive here, and the third quadrant. So first quadrant 60 degree, the third quadrant is 180 plus with 60 degree. That will actually give me 60 degree and then 240. Therefore, my overall solutions will be, if I arrange them in an ascending order, 240, then finally 300. As you can see, both the answer using the previous method and this method is exactly the same. If they are not the same, well, it's time for us to do some rectification. So this will provide an alternative way to check your answer. Always check. Yeah, I stress that checking is the most important mathematical process that you need to make it as a habit. Okay, so I hope this is clear. Okay, now we are ready to move on to the next one. Okay, hopefully I can finish this within the time. Never mind, just let me clean up and then rewrite it. Okay, right. Now, just for reference, I will rewrite the trigonometry identities again. And so it's good to rewrite again and again so that you can remember it quite easily, even though this is given in the data booklet. Okay, equal to secant square, and then finally 1 plus cotangent square is equal to secant here. Right. Okay, so from here, we're going to check which one we can actually use this. Okay, so we found that we have something like a tangent square here. We have secant. If you are given an equation involving a mixture of few types of trigonometry ratio, it's always good to simplify that into a single trigonometry ratio. Okay, so in this case, I'm going to make use of this. Trigonometry ratio here, this identity. Okay, so how am I going to make use of this identity? First of all, I might need to rearrange this a bit. I'm saying that tangent square theta is actually or can be given as secant square theta here minus 1. Okay, so I'm going to use this to substitute that into here. So I can write this as 3. Instead of writing tangent square, I can write it down as secant square x. Okay, this time I need to remind myself it's x minus 1. And then copy the rest that I did not change. So from here, we're going to rearrange. Okay, so that is minus secant x, and then minus 4. Right. So from here, we will get, let me see what we have here. We have 3 secant x. If we factorize this, it should be a 4, and then secant x plus 1. So just let me roughly check whether I'm getting that correct. Yep. Okay, so that will be my factor. So from here, I will have 2 solutions then. Okay, so the first solution is secant x equal to 4 over 3. And then now just to recap again, secant is 1 over cos. So it's best to use cos instead. So I can actually write this as cos equal to 3 over 4. I have already changed it to cos. Okay, it's easier to use cos instead. Or secant x is equal to negative 1 in this case. Or you can say that cos x is actually equal to negative 1, which is the same. So from here, we're going to follow the same rules again to find the solutions for this. Okay. Now, as usual, highlight again the alpha, which is the inverse cosine or arc cos, 3 over 4 here. And then I need to use a calculator on this. I can't remember all the ratio here. Okay, just let me try that out. Arc cosine 3 over 4. Okay, that is 41.4 then. Okay, so I'll write that down, 41.4 degree. And then for this one here, the reference angle will be a bit different because the ratios is different. So the reference angle for this solution is we need to take arc cosine of 1. We are quite lucky in this case. Arc cosine for 1 is actually 0 degree. So to conclude that solutions, the case number 1 here, x would be, because it's a positive cosine, so we are looking at 4th quadrant and the 1st quadrant. So 1st quadrant suggests that it should be 41.4 degree, and then the last quadrant will be 360 degree minus of 41.4 degree. That will give me a 41.4 degree, and then this one will be like 3, am I getting it right? 318.6. Yeah. And then for this one here, the solutions will be, because this is negative, so it should be located in the third quadrant and the second quadrant. So the second quadrant will be 180 degree minus 0. The third quadrant will be 180 degree plus a 0 here, which end up with a single solution, 180. Therefore, we can conclude all the solutions. In this case, we can write that x as 41.4 degree, 180 degree, and then 318.6 degree. Okay. Now, as usual, I will always check because this number is not very familiar to me. So it's always good to check whether we are getting that right. Okay, so one way to check in this case, we have to substitute the solutions that we have back into the original equation. Okay, so just let me roughly check that out. Tangent 41.41 for instance. Okay, 41.41 degree. Okay. Is that a square? Yes, that is a square. So let me put a bracket there because the whole thing is a square. Okay, and then subtract off with a secant 41.41 degree also, and then finally subtract by 1. Okay, so let me see whether I got that right. Okay, done. There's always something not right here. Okay, minus 1 secant tangent square 41.4. Okay, doesn't seem to be right because it's supposed to be 0 here. Okay, just let me double check one more time if I got everything correct. Supposed to be 41. Okay, just let me key one more time. Sometimes my calculator may go haywire. Tangent 41.41 square. This is secant here. Oh yes, correct. So the solution is actually correct. Previously, I think my software a bit out of tune due to the unit that I'm using. So I'm just checking one of them. For the sake of all the solutions, it's best to check at everything. Okay, so checking, I'll leave it to you. Now you can always leave your comment if there's any solutions that is that is not accurate. Yeah, I'm very happy to receive any comment. Okay, let's move on. Okay, maybe this time I'll leave these identities there. Hopefully it does not block my view here. Okay, next question. So solve this within this domain here. Yes, I'm quite lucky I still have this trigonometric identities that I can use here. So in both tangent, so I might as well use the same identity here. So I can rewrite this as 4. So tangent can be written as secant square theta minus 1. Yep. Okay, hold on. I made a mistake here. Maybe because of my bad habit. I'm supposed to write as secant x minus 1 here. Then plus 8 secant x equal to 1. Okay, that will be more like it. Then that will give me secant x plus 8 secant x. And then if I try to solve everything, that should be minus 5 here. So minus 4 minus 5 here. Okay, so just let me try to factorize that. So that will be a 4 secant x plus 1, I believe that. and then therefore I have another factor which is minus 5 equals 0. So just let me roughly check what I have. Did I get it right? No, I did not get it right. I think I accidentally forgot to put this, so I'll try to make the correction here. This is 2, this is a 2 here, so it's supposed to be 2 secant x plus 1, 2 secant x minus 5 there. So just let me check one more time. That is a positive 2. Okay, so there's a positive 2. This part is supposed to be a minus. Yes, good. So this part is a subtraction, this part is a addition. Okay, this time I'm getting it right. Yes, correct. Okay, so there go the factors for this, right? Don't worry, it's fine if you make mistake. You can always correct it. Just make sure you check it one more time. Check it thoroughly. So here we have again 2 solutions. So we have 2 secant x minus 1 equals 0, or we have 2 secant x plus 5 equals 0 here. So from here we have secant x equal to a half, and then we know that secant x is theta. This is a wrong labeling. I hope you're okay with this. Yeah, that's cos x. So I can write down cos x is actually equal to 2, right? But we know that the range for cos x, just as a reminder, the range for cos x, maximum value for cos x is 1. So therefore, this is not a solution. So we will need to reject these solutions here, right? Okay, next we're going to check this out. From here, we will get secant x equal to negative 5/2. Therefore, based on this reciprocal relationship, the cos will be negative 0.4. Okay, so we can work with this because the minimum value should be more than negative 1. Yeah, should be more than negative 1. Negative 0.4 is more than that, right? So we can have this as a solution. Now, as usual, we're going to work out the reference angle. We're going to take the arc cosine. Don't forget, take the positive value here. Okay, just let me check with my calculator. See whether I got this right. Arc cosine 0.4. Let me see what I have. Okay, 66.42. 66.42 degree. And then I need to remind myself that because it's negative, therefore the solutions will be found in the second quadrant and the third quadrant. Then I can finalize my solutions as, in this case, it will be 180 degree minus 66.42, and then the other one will be 180 degree plus 66.42 degree. Then that would give me 113.58 degree. The other one will be 246.42 degree. Alright, so that will be my solutions to this quadratic trigonometric equation. Okay, so I hope that is clear to everyone. Alright. Don't forget, checking. Here I did not check, so maybe you can help me to check whether all the solutions are correct. Okay, so just let me clean this up. Okay. Let me clean this up also. Okay, let's move on to the next one. All right. Okay, so in this case, we are given another trigonometric equations. 2 secant square x equal to 5 tangent x plus 5. So again, I can use the same trigonometric identities here, but instead of rearranging, I can use this directly. I can use this directly because secant square is equal to 1 plus tangent square. So for that, I'm going to write this one down. 2 secant square is actually 2 1 plus tangent square x equal to 5 tangent x plus a 5 here. So by rearranging, I will get 2 tangent square x minus a 5 tangent x here. And then I will get myself negative 3 in this case. Right? And then as usual, I need to factorize that. So 2 tangent x. Okay, let me see. That is minus, so this one must be a plus here. So tangent x minus a 3. So just let me check out one time in case I got this wrong. Okay, so I'm quite happy with this. Therefore, I will end up with 2 tangent x plus 1 equals 0, or tangent x minus 3 equals 0. Here I will have x equal to negative 0.5, or tangent x equal to 3 here. So therefore, if I follow the usual rules, I will need to get my reference angle by getting my arc tangent here. Don't forget, key in a positive value, and then the same go for this arc, which is inverse of 3. So let me get my calculator here. Okay. Let me see whether that works. Arc tangent 0.5. So I got myself 26.6 then. 26.6 degree. Okay, for my second one, arctangent 3. Arctangent 3. That's 71.6. Okay, 71.6. Let me write that down. 71.6 degree. Okay. Alright, so that's 71.6 degree. And then one of these tangent is negative, so if you draw that diagram, which means the solutions will be located in the fourth quadrant and the second quadrant there. Therefore, I can write down x as 180 degree minus 26.6 degree. And the other one is 360 degree minus 26.6 degree. In this case, so just let me simplify that. There's 153.4, and then the other one will be 3433.4. Okay. For this, it will be 71.6 degree. Is located in the first quadrant and the third quadrant. So that will be 180 degree plus 71.6 degree. That will give me 71.6 degree, and then the other one will be 251.6 degree. Okay, so I hope that is clear here. Alright, let's move on to the next one. I try to keep all these identities at the side in case I need them. Alright, now next. Okay, we can see that now in both cotangent and cosecant. So for this, I might need to rearrange a bit like before. So I'm going to rearrange this one here. It will become cotangent square theta is equal to cosecant square minus 1. So I'm going to use this here. So in this case, I will have cosecant square x minus 1 minus 5 cosecant x minus 1 equal to 0. So rearranging, that is a negative 3 here, I think. So let me factorize that one more time. Okay, just let me check that one more time in case I miss out anything. Okay, it's negative 3, negative 3. Okay, that's cool. So from here, as usual, I will have 2 cosecant x plus 1 equal to 0, or cosecant x minus 3 equals 0. Okay, so from here, I'll do this very quickly here. So this is 2 cosecant x equal to negative 1. Therefore, I can say that this is, sorry, I made a mistake here. Just let me clean up for. And then one more reminder on this would be cosecant is 1 over sine. So sine is cosecant. So in this case, the sine x will be negative 2. Because cosecant x is negative 1 over 2, so sine x will be negative 2. We know that sine x is greater than negative 1, less than 1 here. So therefore, this cannot have or cannot produce any solution. Whereas for the second one, we have cosecant x equal to 3, therefore sine x is equal to 1 over 3. Yes, we do expect to have solutions for this one here. Now, by using the calculator, we can find out the reference angle again. Okay, just let me get my calculator very quickly, and then let me key in that 1 over 3. Okay, 19.5 then. Okay, I'll put in 19.5. 19.5 degree. And then we know that sine is positive in the second quadrant and the first quadrant there. Therefore, we can conclude our answer, our solutions will be 19.5 degree. And then the other one is located in the second quadrant, which is 180 degree minus 19.5 degree. That would give me 19.5 degree, and then that would be like 60.5. Okay, so I hope that is clear to everyone. Okay, okay, so just let me clean this up. We can move on to the next question. Okay, I'll try to leave this as much as possible here. Who knows, we might need it next. Alright, now the other applications of trigonometric identities and the reciprocal ratio is for us to prove other trigonometric identities. Okay. For instance, we have question number 1 here. Prove each of these identities. The first identity is tangent x plus cotangent x. Is it the same as secant x multiplied by cosecant x? That's the one that we need to prove. The usual procedure that we are following is, usually we will say that the expression on the right hand side, you can start with any expression at all. We can call this the right hand side expression, this part. We're going to rewrite that. Now the intention for this is we start off from the right hand side expression, and then we get to do some algebraic manipulations, and then with the help of all the trigonometric identities and then some of the reciprocal ratio, to change the form into the form that is shown in the left hand side expression, by the left hand side expression. Sorry. Alright, let's get started. So I noticed that on the right hand side I do have like secant x and cosecant x. So maybe I'll try my best here to do a bit of algebraic manipulation here. Yeah, the other thing you must know of is tangent x is given by sine x over cos x. I hope that you still remember this. And then cotangent is cos x divided by sine x. Okay. Now this mixed fraction here, partial fraction. So I'm going to join these partial fractions together. So once you join them, you will end up with sine square x plus cos square x, in this case, divided by cos x sine x. Okay, now it's just nice. We recognize that sine square theta plus cos square theta is equal to 1. So if we are given sine square x plus cos square x, it must be equal to a 1 also. So just make a remark here, this is actually equal to a 1. Because of that, we can rewrite this as 1 over cos x sine x. And then using divide and conquer strategy, we can rewrite this as 1 over cos x and 1 over sine x. And then using the reciprocal ratio, 1 over sine x is cosecant. And then there's another one which is 1 over cos x, which is given by secant, multiplied by cosecant. And then here we have indirectly proven that this expression on the right hand side is the same as the expression on the left hand side. Okay, so I think I use a different system for my left hand side and right hand side. So just let me correct that. Sorry about that. This is left hand side here, and then I managed to prove the same. I'm getting the same expressions which is indicated on the right hand side expression. So I'm going to write down right hand side. Then I will say that okay, this is proven. Okay, so I hope that is clear to everyone. Okay, so let me clean this up. Then let's get going to the next one. All right, next one. Also need to prove these identities. I'm going to make use of all the identities that I have, and then some of the reciprocal function. Before that, just let me clean this up. Here we don't need to rearrange it, so maybe just let me clean this up so it's easier for us to see. Okay, there's our identities there. I will try to rewrite the reciprocal one more time. Okay, then we might have tangent sometime. Okay, so now we are ready. We're going to start off from the left hand side. Okay, by observing the left hand side expression. I'm going to copy that down just to signify that there is a left hand side. Okay. So here I'm going to do some expansion. Excuse me. So there is secant x. Then this is secant. Did I get it right? Cosecant, negative cotangent, secant. Oh yeah, I missed this out. I miss out the cosecant. And then finally I have my secant x, cotangent x. Okay, just let me check that one more time. Yep, okay, now I'm good to go. Okay. Okay, So from here, you can check whether you can simplify any section at this point. If we can. Yeah, if we can't, is okay. Okay, let's try our luck in this case. Since we can't actually reduce any one of these terms, might as well we turn into our reciprocal here. So this is 1 over sine x. Cotangent is cosine x over sine x. Yeah, I need to write that for reference here. So tangent theta is sine cosine, whereas cotangent is cos theta over sine theta. Yeah, that's that. And then secant x is 1 over cos. Cosecant is 1 over sine. This is the same cos. And then cotangent is cos x over sine x. Okay, this is what we have at this point of time. Okay. So from here, we notice that we can sort of simplify this. That will give us negative 1 over sine x. Then we notice that this is positive sine x, that is negative sine x. Therefore, we can cancel these two terms there. Okay. So what is left behind is basically just negative cos x sine x plus 1 over cos x 1 over sine x. Okay, that's what we have. And then we recognize that both of these have a common factor. Maybe it's better to factorize this out. What we have now is negative cos x plus 1 over cos x. Okay, and then further simplify this. So we can join these together. That will become 1 minus cos square x over cos x. Okay, and then from here, 1 minus cos square is actually sine square. Therefore, we can rewrite this as sine square x over sine x cos x. Therefore, we can reduce this, become sine x over cos x. Yeah. Now, of course, to be safe, in this case, we are cancelling sine x with sine x, provided x is not equal to 0, though. Especially when you are trying to analyze functions. That's just for extra reference. So from here, we notice that that is equal to tangent x, which is the same as the expression indicated on the right hand side. So therefore, we have proven this. Okay, so I hope that is clear here. All right, so I'm going to move on to the next one. We'll leave the rest of the information at the side there. Hopefully it's useful to us. Okay, next. So prove this. Basically, it's up to you which side you want to start to perform your proof. It's either you can start from right hand side or left hand side. Okay, doesn't matter. In this case, I might as well show you two different ways. Okay, I'm going to instead of starting from left hand side just now, I'm going to start this time from right hand side. I'm going to observe the expression on my right hand side, which is given as this. Okay, then yeah, it's easier to expand. In this case, you can see that there is actually tangent x plus 2 tan x secant x plus a secant square x. Mhm. And then from here, we notice that we have secant square. So secant square is actually 1 plus tangent square. So I might want to use that. So secant square is actually 1 plus tangent square. Okay. So from here, I will reduce it further. So there's here plus 2 tangent x secant x plus a 1. Plus a 1. Okay. And then finally, because the left hand side only show sine, so I might want to turn the tangent into sine over cos square, and then do the same for this. Secant, as we know, secant is 1 over cosine, so I'm going to put that cosine plus 1. Okay. And then I can sort of join everything up together. So that will be a 2 sine square x plus 2 sine x, and then plus, if I combine everything, that will be a cosine x over cos square x. That's what we have at this point. Okay, so I hope that is clear here. And then after that, all you need to do is just concentrate on this identity. We know that that is uh, cosine x. If you want to change cosine x, so cosine x is given as 1 minus sine square x. So we will put this as, I'm going to write it at the side, hopefully I have enough space here. So sine square x plus 2 sine x, then this is 1 minus sine square x cos square x. So you'll notice that this sine square and this sine square can be reduced. So that would actually give me a sine square only, and then plus with 2 sine x, and then finally don't forget there's a plus 1 over cosine square x. And then we can factorize the numerator in this case. That is basically 1 plus sine x squared. And then the denominator can be written as 1 minus sine square x. And then by using that identity, a square minus b square is equal to a minus b, a plus b. We are going to apply this onto the denominator. So therefore we can cancel off the 1 plus sine x. Therefore we only left with 1 plus sine x over 1 minus sine x. Okay, so I take a bit of shortcut here due to my limited space, but you guys can always check out this section here especially. So these are the sections that you need to check that out. Okay, so hopefully everything is clear here. Alright, so I'm going to move on next. This one I'll erase it off. Okay, next. Alright, now, okay, this time it's blocking the way, so I'm going to clean up everything. I hope that you guys can remember the identities that we're going to use. So the next one we're going to work out is some other applications. Then. Are we able to express this trigonometric expression in this form, for instance? Yeah, okay, let's give it a try. Okay, so in this case, we can rewrite the expression first. Okay, and then always check the requirement. They want it to be sine square. So I'm going to rewrite one more time. Sine square plus cos square is equal to 1. Therefore, cos square x is always equal to 1 minus sine square x. So we're going to make use of this. That will give us 2 1 minus sine square x, and that would give me hold on, so that is actually a 2 sine square x minus a 2. Okay, that will give me a 7 sine square x minus a 2, and then by rearrangement it's actually negative 2 plus 7 sine square x. Okay, so I managed to express this in this form. Okay, all right. Okay, once you're done, B, state the range for these functions within this domain here. Now, the easiest way to identify the range for this is, let's work out the minimum value. Minimum value of negative 2 plus 7 sine square x is the minimum value. The minimum value in this case, is it minimum value? Let me see. I wouldn't say the minimum value though, because, okay, hold on, just let me change that wording a bit. Okay, we know that sine x, the range for sine x is line between negative 1 and 1. Okay. So therefore the maximum value for sine is a 1. Minimum value is 1. But because of the square, it does not make any difference in this case. Okay, it does not make any difference. Okay, but we also know that the maximum value is 1 here. So therefore, I think it's best for me to work out the maximum value of negative 2 plus 7 sine square x is, because the maximum value for sine x is 1, so therefore the maximum value for this is negative 2 plus 7, which is equal to a 5. This is the maximum value. Now what will be the minimum value then? This will be minimum. Okay, let me write that down. Minimum value of negative 2 plus 7 sine square x is, the lowest value that you can expect here will be 0 for sure. So therefore the lowest value is negative 2. And then because of that, we can conclude that the range. I'll just rewrite up here. So the range for these functions would be lying in between. Okay, just let me write fx is easier to use. Fx lying in between a 5 and a -2. Okay, right. So I hope that the way to get the range is clear to everyone. Alright, so let's move on. Let me check whether I still have any more questions to attempt here. Okay, let's see. Okay, I think this is the last one though. Yes, correct. This is the last one. Okay. Now the same thing, express this in this particular form. Okay. Alright, now this would actually be a recap on completing the square. Okay, I hope you guys still remember how to complete the square. So let me show you one more time how to complete the square. If you are not very comfortable with sine square here, by all means, change it to a different letter to represent the equations. But before that, we will need to rewrite this so that it only consists of single trigonometry ratio. Because it consists of mixture or trigonometry ratio, is tougher to handle here. Therefore, it's better to convert it into one trigonometric ratio. Okay, so maybe in this case, we're going to recap using sine square. Sine square theta is equal to 1 minus cosine square theta. Okay, so we're going to make use of that. That will be 1 minus cosine square theta plus 4 cos theta plus 2. And then through rearrangement, we will have negative cos square plus 4 cos square, cos theta, sorry, plus 3. That's the equations that we are having, quadratic equation. So now we are going to complete the square for this. Sometimes if this cos is not very comfortable to you, you can let I think you guys are more comfortable with x, so let x be cos theta. Therefore, this will be x squared plus 3. Working out this is much more easier by completing the square in this case. So therefore, the completing the square would be that will give us a negative x minus 2 square plus a 7. And then to finish this off, we can say that this expression can be written as negative cos theta minus 2 square plus a 7. Alright, so I hope that is clear to everyone. That is the format that we want. Of course, they want to rewrite that in that order, so I will write that in this order then. Okay. In the exam, if you like, you can label A as 7, where the B is 2. Okay, that will conclude the answer for A. Okay. So from here, the purpose of completing the square is for us to identify the minimum or maximum value here. Right? Now we know that in this case we are getting a maximum. And we are actually getting a maximum value because based on our quadratic equations, if you just look at the quadratic equation itself, the coefficient for x squared is a negative. So you will expect to get a maximum value. So here, we are going to state the maximum values. So what will be the maximum value? The maximum value of sine square theta plus 4 cos theta plus 2 is 7. It's 7 when cosine theta minus 2 is equal to 0. So when cosine theta minus 2 is equal to 0. Right, so just let me check one more time. And this cosine 2, and then in this case the cosine theta is equal to 2. Cosine theta is equal to 2. Now we do recognize that cosine theta maximum value can only be 1. So therefore, in this case, we have a problem here. So we need to check thoroughly here what is going on here. Are we going to get a maximum value of 7 then, when cosine theta is equal to 2, which is not possible in this case? So we have to rethink again just to check whether we got everything's correct. Okay, so just let me check one more round. Let it cosine plus cosine is a 3. Okay, just check one more time. So that is a negative cosine square minus that. Alright, so when cosine theta is equal to 2. Alright. Okay, so let me think for a while. Let me pause for a while. What is going on here then, if you must be wondering? So this is the usual way how you work with your completing the square. You would straight away say that because of the coefficients is negative, therefore you will expect a maximum value of this is 7 when this is equal to 0. But later on we found that I can't have any solutions for this because the cosine is lying between 1 and negative 1. Now you see that completing the square form is only limited to polynomial, but when it comes to trigonometry, we have to be a bit careful here. So just let me summarize that. So it's good for thinking. Can you see that I'm pondering myself also? All right, it's good to have some second thoughts. Okay, so I'm going to clean this up. That is just for your reference. So bear in mind. Okay, now let's come back here. Let's recall. We know that cosine theta is lying between 1 and negative 1. That's the information that we must pay attention to. Therefore, the maximum value for this would be the maximum value. What would be the maximum value we expect to get here? So the maximum value for this is when cosine theta is equal to 1. When cosine theta is equal to 1, it means that you will get the lowest value here. So the lowest value that you expect to get is actually when cosine theta is equal to 1, when this is equal to 1. So when this is equal to 1, this expression inside the bracket will become the smallest. Therefore, you expect the largest value for this expression. So the maximum value is 7 minus 1 minus 2 square here, which is equal to 6 when cos theta is equal to 1. Okay. And then next, because the trigonometry functions fluctuate to maximum and minimum, so what will be the minimum? The minimum value is, you will get minimum when this part is the largest. So the largest that you can get is 7 minus -1, -3. So in this case, you will get a -2 when cosine is equal to -1. Because when cosine is equal to -1, this expression will become the largest. Therefore, your overall value will be the smallest. And then there you have it. Okay, something to think about, and then something that you can relate to completing the square. But the final part is the most important. So I hope this has been useful information to everyone. Right? As usual, if you like the video, do subscribe and then press the notification bell to receive a future video feed. Right? Thank you very much.